Welcome to Grab and Go Info. Today I will talk about how to use Isolation Forest for anomaly detection. Isolation Forest uses the number of tree splits to identify anomalies or minority classes in an imbalanced dataset. The idea is that anomaly data points take fewer splits because the density around the anomalies is low. Python's sklearn library has an implementation for the Isolation Forest model. Isolation Forest is an unsupervised algorithm where the actual labels of normal versus anomaly data points are not used in model training. In this tutorial, you will learn 1. What is the Isolation Forest model? 2. How to build an Isolation Forest model using Python. 3. How to use an Isolation Forest model to do anomaly detection. 4. How to continue training an Isolation Forest model using new data. 5. How to continue training an Isolation Forest model using more trees. Let's get started. The first step is to import libraries. We need to import make classification from sklearn to create the modeling dataset. Import pandas and numpy for data processing. Counter will help us count the number of records. We also need the train test split to create training and validation dataset. Isolation Forest for modeling. And classification report for model performance evaluation. Using make classification from the sklearn library, we created two classes. The ratio between the majority class and the minority class is 0.995 to 0.005. Two informative features were made as predictors. We did not include any redundant or repeated features in this dataset. The output shows that we have about 1% of the data in the minority class and 99% in the majority class. The third step is to do a train test split for the imbalanced data. In this step, we split the dataset into 80% training data and 20% validation data. Random state ensures that we have the same train test split every time. The seed number for random state does not have to be 42, and it can be any number. The train test split gives us 80,000 records for the training dataset and 20,000 for the validation dataset. Thus, we have 79,183 data points from the majority class and 817 from the minority class in the training dataset. In step 4, we will train an Isolation Forest model. Isolation Forest identify anomalies by isolating outliers using trees. The steps are: 1. For a tree, randomly select features and randomly split for each feature. 2. For each data point, there is a splitting path from the root node to the leaf node. Calculate the path length for each data point. 3. Repeat step 1 and step 2 for each tree. 4. Get the average path length across all trees. The anomalies have a shorter average path length than normal data points. We train the Isolation Forest model using the training dataset and make the predictions on the testing dataset. By default, Isolation Forest labels the normal data points as 1s and anomalies as -1s. To compare the labels with the ground truth in the testing dataset, we change the anomalies labels from -1 to 1, and the normal labels from 1 to 0. The model has a recall values of 38%, meaning that it captures 38% of the anomaly data points. Isolation Forest supports a warm start, which can train trees in addition to the existing model. In step 5, we will train Isolation Forest model on new data with warm start. Suppose we collected more data after training the model. Then, we can utilize the new data collected and train on top of the existing model. Let's create more data using make classification. We set the option of warm start equals true for the original Isolation Forest model, then added 50 trees trained on the new dataset. We see a 1% increase in the recall value. Even when no new data is available, we can still train the Isolation Forest with a warm start to improve model performance by introducing more trees. Step 6 shows how to train additional trees using the same modeling dataset. We can choose to keep training the isolation model using more data, more trees on existing data, or use both. In this tutorial, we went through how to use Isolation Forest to make anomaly detection. Using the sklearn library in Python, we covered what is the Isolation Forest model, how to build an Isolation Forest model using Python, how to use an Isolation Forest model to do anomaly detection, How to continue training an isolation forest model using new data. How to continue training an isolation forest model using more trees. If you found the information in this tutorial helpful, please click the like button and subscribe to the channel. I publish tutorials on machine learning, deep learning, and natural language processing every week. If you prefer the written version of the tutorial, please go to grabandgoinfo.com. I will put the link in the video description. This is the blog post for this tutorial. It has all the code and explanations in this video. To learn about detecting anomalies using a supervised model, please refer to my other videos. One video is about ensemble oversampling and undersampling for imbalanced classification using Python. And another video is about neural network model balanced weight for imbalanced classification in Keras. Thank you for watching. See you in the next video.